Hola a todos y a todas, bienvenidos a el webinar del día de hoy. Este webinar tiene como título Compuestos a base de madera, biodegradables, duraderos y mejorados por la investigación en con inteligencia artificial, o en inglés, como lo titulamos, With Based Composites, Biodegradable, Durable and Enhanced by Artificial Intelligence Research. Mi nombre es Sara Piedrahita Rodríguez, yo soy ingeniera química, tengo un doctorado en ingeniería química también de la Universidad Nacional de Colombia y actualmente hago parte del Instituto de Investigación en Ingeniería INCUBE de la Universidad Cooperativa. Aquí estoy realizando mi estancia postdoctoral en el proyecto Orquídeas Mujeres en la Ciencia. El profesor Fernando, nuestro director del instituto y CEO y fundador de la red Verstic, que iba a moderar la sesión, pide excusas pues porque no puede estar acá, sin embargo, yo los voy a estar acompañando en las charlas. Bueno, para comenzar, les cuento que este webinar consta de dos ponencias. Tenemos dos ponencias de aproximadamente 10 minutos cada una. Al final de ellas vamos a dar otros 10 minuticos de preguntas para que se animen a preguntar en el chat. Pueden colocar esas dudas allí. También recordarles que esta sesión está siendo transmitida por nuestro canal de YouTube y también por la plataforma de Verstic Live. Y finalmente, pues luego de las ponencias, los invito a no desconectarse, pues vamos a dar una información muy importante relacionada a la red Verstic y también pues a las oportunidades que tenemos para pertenecer a ella, ¿vale? Bueno, para no hacer más larga esta introducción, vamos a empezar con las ponencias. Inicialmente quisiera presentar a nuestro primer ponente, el profesor Kowaluk, es ingeniero en tecnología de la madera, con un máster graduado por la Universidad de Ciencias de la Vida de Poznań en Polonia, especializado en el procesamiento mecánico de la madera. Su tesis doctoral que defendió en la misma universidad contribuyó a sus conocimientos de ingeniería, ya que se ocupó de la fracción y las fuerzas de corte durante el fresado de compuestos a base de madera. También amplió sus conocimientos de ingeniería y organización en el Instituto Tecnológico de la Madera de Poznań en Polonia. Fue jefe de proyecto de materiales compuestos fabricados con una nueva forma de materia prima, que son las virutas fibrosas. Y actualmente en la Universidad de Ciencias de la Vida de Varsovia, en Polonia, es responsable del proyecto Horizonte 2020, CELICE, y un proyecto internacional de la convocatoria Forest Value 2021, BART-Build. Participa activamente en el desarrollo de estudiantes, tutelando más de 100 tesis de ingenieros y de máster. Su actividad profesional actual se centra en la utilización racional y óptima de materias primas, especialmente de biomasa, en la tecnología de los compuestos de base de madera. Es inventor también de 2 patentes. Entonces, pues muchas gracias al profesor Kowaluk por estar acá. Thank you, professor. You can start with your presentation, share your screen, and so on.
Buenas tardes para todos. Can you hear me?
Yes, you can.
Okay, thank you, Sarah, for very nice introduction. I'm very happy that I can present a few slides about my experience regarding wood-based composites. First of all, I would like to say that this presentation is part of my secondment completed under CELICE project, and I would express my big thanks for Professor Fernando, because without his contribution, that secondment could be not possible. Okay, let me start. Lightweight, biodegradable, and durable particle boards, and this title could be for you a kind of misunderstanding, because I am trying to say about 3 different panels instead of one, which is lightweight, biodegradable, and durable. It's not possible, probably. So let me start with first topic, which is eco-friendly panels with lower density. In furniture production, a big pressure is put to lightweight panel, because the mass, which is moved from the plant to the user of the furniture, it generates costs, because if the furniture is heavy, you have to use a heavier truck, or you can put for the truck less material instead of lightweight panels. That's why we tried to replace partially the wooden particles by foamed starch. As you see on the right picture, these foamed starch are typically used for sending fragile materials with the couriers to avoid the destruction. So the bulk density of that material is very low. It's something like 8 kilograms per cubic meter. For example, the particle board is made from particles which bulk density is between 200 and 300. So that's why we try to replace the wooden particles by this foamed starch. And these are the list of parameters that we applied to make these panels. So the most important is the foamed starch share in the panel. So it was reference panel like 0% and 5, 10, and 30% by weight in core layer only. The thickness was 28 millimeters. It's quite thick because it's probably can be used for tables. The density should be lower. That's why it's 500 only. 3 layers because outer layers are made of smaller particles. And the rest of the parameters are more or less typical, more or less used in wood-based panels industry. And we tested bending strength, modulus of elasticity, internal bond, and swelling in thickness. And here are the first results. A modulus of rupture on the left plot are the white boxes. As you can see, the best parameters we found for panel with 5% of foamed starch content, and the additional amount of foamed starch leads to decreasing modulus of rupture. The same structure of the strength is for modulus of elasticity, that the best parameter is for 5%. On the right plot, you can see the internal bond properties, and you can see that when you check the standard deviation lines, it looks more or less the same. No statistical differences between the different variants. So we can conclude in that research that according to the European standard, as you can see below, the requirements for modulus of rupture is almost 10 megapascal, and we found it only for this 5% panel. Modulus of elasticity minimal strength is 1,350, and we found it also for 5% panel. And internal bond was met for all the tested panels. And regarding swelling thickness, it's significantly growing with increasing foamed starch content, but also the best parameters are for 5% content. And on below, you can see the sample of the panel before and after soaking in the water. So these light zones are the foamed starch in that panel. Second topic are the panels with waste particles from veneers of exotic species. It's not very common alternative raw material as we tested, but sometimes we can collect different exotic species of wood. And as you probably know, these different species has different parameters, like, for example, resistance for moisture, for water. So the main parameters, as you can see, are the amount of particles from exotic wood species. It's like 0 for reference panel, and 10, 30, 50, and 100 by weight in core layer only. Since the thickness of the panel was 12 millimeters only, then density was higher. It was 750 kilograms per cubic meter, and the remaining parameters are also similar to industrial one. And what we found that in case of modulus of rupture, this excess, the strength is more or less the same when you adding more exotic wood particles content to the core layer, but the panels are more stiff. As you can see, this slope is up when you adding more exotic wood particles content. So it means that this is good solution for that application, that panels are more stiff, and also these panels meet the requirements of European standards. Very important thing is that some of the panel breaks sometimes in the middle of the thickness. So it is information that internal bond is too low for that panels, as you can see on that example of the picture. And how it looks like during the test, you bond the surfaces of the sample between two metal blocks and you pull them out, trying to destroy the sample. But in case of that panel, the internal bond was very high. You can highlight that internal bond minimum internal bond should be 0.45 megapascal. But these all tested samples has more than double this strength, so it's very good. And regarding the swelling thickness and water absorption, you can see that with increasing content of particles from exotic wood species, the water absorption goes down, significantly goes down. So it confirms that these exotic wood species particles are more resistant for the moisture. And the last topic in my presentation is the reduction of flammability of particle boards. We tried to do it as much as natural can be. So we, as you see, we blended, we mixed, we milled the eggshells, which are actually the waste. But you have to remember that these eggshells are calcium carbonate, which emit the gases that are not flammable during the heating of that particles. So we decided to add these calcium carbonate particles to the surface layers of the panels. So we added 5, 10, 30, and 50% by weight to surface layers only, because we assumed that when fire comes, it acts on the surface of the panel. And the rest of the parameters was like 20 millimeters of thickness, density was quite high, 750 kilograms per cubic meter, three layers, and remaining parameters close to industrial. And what we found? We found that in case of modulus of rupture, the trend was very high. As you can see, this upper line, and also the stiffness was strong enough to give us the parameters required by European Union to create the furniture. And also internal bond significantly grows with the calcium carbonate content growth, as you can see on the right plot. And how it works with swelling in thickness? The swelling in thickness significantly goes down with the calcium carbonate content growth. It's easy to understand, easy to explain, because these calcium carbonate particles do not absorb the moisture and do not expand with the contact with the moisture. And also water absorption goes significantly down with increasing content of calcium carbonate. These are the results of length of burned path for the different samples with different calcium carbonate content. As you can see, the highest content of the calcium carbonate particles in the surface layers leads to a reduction of the length of burned path, because in that research, in that test, you put the flame to the surface of the sample, which is vertical position, and you use the flame for the exact period of time, like from 30 seconds to 5 minutes. And you can see that the length of burned path goes down with the increasing calcium carbonate content. So we are happy to have these results, and you can see the samples after the test. Here you can see the length of the burned part after 2 minutes and after 5 minutes, and the right sample is the highest content of calcium carbonate. And after a few years of our research, because it was students' project, we found in the literature that someone did similar test, calling it eggshells and novel biofiller for flame retardant coatings. So we are happy that our ideas go in the proper way. In case of utilization of eggshells, we also did the research to use the calcium carbonate particles as a filler in plywood, and also we got very nice, very interesting results. And this year, in this January, we have a publication with my student about this research. So the conclusions: it is possible to find a technology to produce the eco-friendly panels with lower density, like with that starch, and the panels with the waste particles from the nears of exotic species provides very, very interesting parameters. They are strong and durable, and also we can reduce the flammability of particle boards with using 50% of calcium carbonate in the surface of the panels. So I hope I meet the requirements to fit to 10 minutes, and thank you for your attention.
Thank you, Professor, for your presentation. It was very interesting. Gracias al profesor Kowaluk. Recordemos que las preguntas que tengan las pueden hacer en el chat de YouTube. Ahí tenemos disponible el espacio. De todas maneras, yo acá tengo una pregunta que nos llegó. La voy a leer en español y procedo a leerla en inglés para traducirla al profesor. Por acá preguntan, si probaste con varias especies de pollos para las partículas de los huevos. Professor, did you try different species of chickens for the eggs particle?
Chicken, you mean the chicken
Yes.
eggshells, yeah? Yeah.
Exactly.
Yeah, that's true. Because it's, as I said, it's calcium carbonate, it's not flammable, but emit the gases that reduce the flammability of materials.
Okay, thank you. Por acá no sé si hay alguna otra pregunta, si no procedemos a la siguiente ponencia y pues vamos a continuar. ¿Listo? Muchas gracias al profesor. Ahora quisiera dar paso a nuestra segunda ponente. Ella es Anita Wronka. Ella es estudiante de doctorado en la Escuela Doctoral de la Universidad de Ciencias.
Okay.
Denme un segundo acá. Listo.
Thank you for the introduction. Can you see my presentation and hear me well?
Yes. Let me introduce yourself for the presentation. Ella es estudiante de doctorado en la Escuela Doctoral de la Universidad de Ciencias de la Vida de Varsovia, en Polonia. Anita es ingeniera en diseño de muebles y máster en tecnología de la madera de la Facultad de Tecnología de la Madera de la Universidad de Ciencias de la Vida de Varsovia. Su tesis doctoral se centra en el reciclaje de materiales derivados de la madera, principalmente tableros de partículas, carpintería de ventanas, puertas por postconsumo y tableros de fibra de densidad media y alta. Su investigación se basa en los principios de la economía circular. Actualmente es jefe del grupo científico de estudiantes de la Facultad de Tecnología de la Madera en la misma universidad y miembro del Consejo Doctoral de la Escuela de Doctorado de dicha universidad. Muchas gracias, Anita, por estar acá. Thank you, Anita, and welcome. And you can start with your presentation. Go ahead.
Thank you one more time for the introduction. So the topic of my presentation is artificial intelligence in literature research. As Grzegorz mentioned, every research need state of art, so it is very important. And today I would like to compare a few methods, but at the beginning I would like to tell you about traditional literature searching, which is time consuming and may overlook relevant sources. It's also combining traditional method with AI tools speeds up to literature analysis, and AI-based tools significantly improve the efficiency of this process. So as you know, traditional method, we just to try to find articles by Scopus, ResearchGate, or Google Scholar. So this process is very time consuming. And as I mentioned, we use Scopus, Google Scholar, PubMed. We can find reviving articles and analyzing citation. And we need to manually filtering and assessing the quality of sources. So the main advantages of this method is, of course, full control over the search and selection of sources, ability to thoroughly evaluate the quality and relevance of results, and we need to use of advanced filters as a DOI, date range, and other. And the disadvantages of this method is, of course, time consuming, as I mentioned, especially with a large number of publications, requires knowledge of advanced search techniques, and difficult to detect connection between articles beyond citation. And the first tool which I would like to tell you is ResearchRabbit. Is a tool for discovering related scientific papers, and it visualizes citation networks and relationship between articles. And how it works: you search for one article using, for example, the title or DOI, and ResearchRabbit shows you related papers. You can explore citation networks, discover aerial and later studies. And the application, ideal for finding new publication and tracking research trends, allows you to create subjects collection and share them with your team. And the main advantages: interactive visualization of connection between articles and authors, facilitates exploration of new sources and trends, allows creation of personalized literature connection. And the main disadvantages are doesn't always provide full text articles, but it happens in the other methods also, and may suggest less relevant publication depending on the algorithm. And if you would like to try ResearchRabbit, I put here a QR code and you can try it. And of course, it is for free. Here is an example how it works. On the left side, you can see the article which I choose. Here I have the title, and the next section you can see also abstract, and I choose similar work, and then now we can see similar research from other. And on the right side, you can see the connection, and of course you can choose, and it can be a great inspiration to see other experiments from other researchers. The next tool is Consensus. It's a tool that allows you to ask scientific questions and get answer based on the literature. Instead of individual articles, we get a summary of research. And how it works: you type in a question such as, do biopolymer improve OSB properties? And Consensus analyzes hundreds of publications and presents a synthesized answer. And application: quick verification of research hypothesis, efficiency browse the literature for specific conclusion. And the main advantages are analyzes article content and provides summaries based on research findings, helps assess the overall scientific consensus on a topic, facilitates searching for answer to specific questions. And the disadvantages: limited database compared to Scopus or Web of Science, may overlook less popular but significant studies. This is very helpful tool. And now I can show you the screenshot from the from this website. This one is also for free, so you can try every time when you want. And my question was, can coffee or its waste be used in wood composites? And here you can see the answer. We can see also a few sections. It's depend from we would like to use. Here we have types of coffee waste use and application and benefits. If you put on the number, the consensus will take you to the whole article, and you can also see the abstract. And the third tool I would like to tell you is Scopus AI. It integrates AI into the Scopus database, enabling intelligent search for publication, helps discover non-obvious links between studies, and allows precise filtering of results by citation, keywords, topics, analyzes research trends, and identifies key publication in a given field. And application is perfect for systematic literature revise, facilitates identification of research gaps. And the main advantages uses the Scopus database, ensuring high quality sources, enables intelligent search and suggests related studies, allow quick review of citation and trends. And disadvantages: access is limited to subscribers. The university must pay for access, and we had an experience with that, and I really recommend this. And requires verification of the relevance of suggestion also is a disadvantage. And now I would like to use a movie from the internet to show you how it looks. We put also the question, and then at the first part we get an answer, but if it's not enough for us, we can choose expanded summary, so we will get more information. And also I will show you in a moment. Here we have expanded. Also we have here numbers, concept map. So in my opinion, it is combining two previous tools. If you don't have an idea in which way you should develop your research, you have also extra topics which you can choose, and the Scopus AI will show you the answers. Okay, this is the most important. Sorry. Oh, okay. So all of these tools are also easy to connect with Mendeley and Zotero, in which we are probably working in every day. So it's very comfortable. And the conclusion: traditional searching offers more control and allows for in-depth quality analysis, but is time-consuming. AI tools automate the research process and help discover new sources, but they require verification and might miss less popular studies. So the best strategy is to combine methods using AI for quick exploration and discovering connection, while relying on traditional methods to verify and select key publication. And thank you for your attention.
Thank you, Anita. Thank you for the presentation. It was so interesting too. Gracias, Anita. Ahora me gustaría recordarles que pueden hacer sus preguntas en el chat. Nos han llegado otras preguntas para el profesor Kowaluk, entonces pues voy a leer esas preguntas para tener la discusión y retomo si hay preguntas para Anita. ¿Listo? Primero, hay varias preguntas en el chat para él. Inicialmente preguntan si el proyecto de almidón espumado primero, ¿cuál es el costo de reemplazar con almidón espumado? ¿Qué tipo de aplicaciones comerciales hay? Y cómo se obtuvo el almidón como tal. Entonces, paso a comentarle las preguntas en inglés. Professor Kowaluk, the first question is, in the project of formed starch, first, how is the cost of replacing with foamed starch?
Okay, the price of replacing these materials is probably the 10% of wooden particles, because it's very volumetric material, this foamed starch. It's very cheap because it's actually a lot of air inside, but the prices of wood are much higher. So I can estimate it as a 10% only of the price of wood.
Okay, thank you. The second part of this question is, what sort of commercial application does they have?
Well, we didn't commercial it yet because these are quite new research regarding this foamed starch, but we see the commercialization in the production of the tables because of the thickness, and the technology is easier to get the lower density with the materials that have the higher thickness. So that's why our vision is to produce the tables, and sometimes as a filler for example, for doors, because sometimes you need the lighter materials but of higher thickness. For example, for the doors, it works like insulation, also of thermal isolation, but also acoustic isolation. So this is good material. That can be the purpose of that material.
Perfect. And the third part of this question is, the foamed starch, how were obtained? Using what type of raw material?
Well, actually, you can produce this foamed starch from every kind of starch, even from lower quality starch, which is not provided for human food, for example. So lower quality starch can be translated, for example, for that foamed starch, because it's not complicated technology, and yeah, every kind of starch.
Perfect. The second question, I will read in Spanish first and then in English. La segunda pregunta que hacen también aquí para el profesor Kowaluk es, el proyecto de especies de maderas exóticas, primero, ¿cómo se protegen las especies exóticas en Europa, teniendo en cuenta su potencial de captura de CO2 y la protección de la calidad del suelo? Esa es como completa la pregunta. So in English is, in the project of exotic wood species, how are the exotic species protected in Europe, having in mind that a potential of CO2 capture and protection of soil quality, etc.
Okay. Well, let me start with the idea that exotic wood is very expensive in Europe. So the Europe tries to control the market of exotic wood by, like for example, forest stewardship, forest FSC. That's the short name of the organization, the Forest Stewardship Council, that control the market of exotic wood, but not only exotic wood, but the special force is put to this exotic wood, since the prices of that wood are very high. And also this way they try to avoid the uncontrolled market of different kind of wood, especially to avoid the taking wood from the places, the forests that are the planet creating the CO2 collection. So and I can say that our approach to use this waste exotic wood was because sometimes you you use the veneers, and the veneers are a very thin part of wood. The thickness is less than 1 millimeter, and the remains from that cutting of these veneers you can use for our approach to produce the particle board instead of burning, because the last step of utilization of that waste are burning. Well, we call it now energy production, energy recovery, but these two activities are emitting the CO2 to atmosphere. So our approach was to prepare the particle board and to fix this CO2 in these panels for longer time instead of emitting it.
Thank you so much. And the third question is in Spanish. ¿Qué tipo de comercialización potencial visualiza en un futuro próximo para esta idea y qué resultados hay prometedores? So what sort of potential commercialization do you vision in the near future for this promising idea and results?
Well, when you try to commercialize the raw materials that are not popular in the zone of or country that you live, it's very hard. It's very hard because the producers of that materials are very strong companies. They are huge. They have a big money, but in fact they give the job for a lot of people in these locations. So it's very hard to discuss with them. Let me try to test this new alternative raw material instead of that wood that you know, and you know how to use it from many years. So it's very hard discussion with them. So I think the beginning of commercialization can be the small companies like spin-offs, spin-outs with lower production, but maybe with the higher added value for that product. So because it's as I said, it's very even impossible to compete with that huge producers of regular particle boards, for example, that are used for furniture. So we should start with the smaller companies, but produce high or higher added value products.
Perfect. Thank you, profesor. Gracias al profesor Kowaluk. Acá en el chat también aparece una pregunta para Anita. Voy a hacer la misma dinámica, leerla en español, luego en inglés. Preguntan, ¿la herramienta Scopus de inteligencia artificial es gratuita o cómo podemos acceder teniendo acceso a Scopus directamente? So, Anita, the question is, the Scopus AI tool is free, or how we can having access to Scopus?
Thank you for the question. So, as I mentioned on my presentation, the Scopus AI tool is paid. The university is paying for that, and we had this opportunity to use it. And how can we have access? So I think the university needs to make a cooperation with Elsevier and Scopus, and this is, I think, the easiest way to take this access.
Thank you, Anita. Gracias, Anita, por la respuesta. Creo que no tenemos más preguntas. Déjenme revisar aquí en el chat. Bueno, también para Anita hay otra pregunta. Para un estudiante de pregrado o un investigador que está empezando, en tu opinión, ¿cuál es más amigable? So, this is another question for you, Anita. For a degree student of a beginner researcher, in your opinion, which is more beginner friendly? Of the platforms of...
Oh, it's working. Okay, yeah, I need to a while to think about that. In my opinion, very helpful is consensus, because you get an answer in a while. In fact, the research rabbit is a bit more complicated because you get the other articles, and you need to take more time to read, for example, abstracts and other things. And a consensus get the answer faster and suggest which part you should use. So it is faster and easier for the beginners, in my opinion. And of course, it's for free. So both of these, the easiest from all of them, in my opinion, is Scopus AI. But for free version, consensus will be good.
Perfect, thank you, Anita. Muchas gracias a los ponentes, también a los participantes en las preguntas. Ya pues daremos por finalizada esta sesión del webinar, que estuvo muy interesante. Ahora en estos minuticos les voy a comentar unos avances que tenemos, últimas noticias relacionadas con la red Versic. Entonces, pues les queremos contar que estamos prontos a realizar la próxima semana un lanzamiento de la nueva página web. Entonces, para que estén súper pendientes, estamos muy emocionadas porque la conozcan, interactúen, puedan encontrar en esa página diversas oportunidades. Por ejemplo, los servicios y productos que ofrecemos, las oportunidades relacionadas con mentorías, consultorías, coaching, en diversos temas de economía circular, de transición energética, transformación inteligente, educación, cultura para la paz. También encontrarán un portafolio de productos en el desarrollo de nuevas tecnologías como son los gemelos digitales, Digital Twins, entre otros. También la oportunidad de pertenecer a comunidades de práctica como los semilleros de investigación y otras iniciativas. La idea es que exploren mucho la página, que estén muy pendientes también de nuestras redes sociales y pues allí encuentren esa posibilidad de oportunidad para sumarse a la red Versic. Así pues juntos podremos proponer y aplicar soluciones que transformen verdaderamente. Y pues recordar que en Versic creemos en la investigación, ya que es el motor de cambio y con ella podemos enfrentar pues los retos del futuro. Finalmente también aprovecho para contarles que estaremos realizando más webinars de este tipo, enfocados a diferentes temáticas relacionadas también con la red Versic, pero también de aquellas relacionadas con desarrollo personal, que también es una parte interesante y que debemos tener en cuenta pues a nivel integral, holístico, ¿cierto? Entonces, muchas gracias a todos por su asistencia. Thank you very much for the presentation of the Professor Kowaluk and Anita. Espero que tengan un buen día, un abrazo y seguimos conectados.